Welcome to Operations and Supply Chain University. I'm Jerry Wright. This is lesson number 8, Value Stream Mapping, Part 1. So the theory of value stream mapping really means learning to see. This was a book that was written by John Shook and Mike Rother. Educator and author Mike Rother developed the VSM idea or concept from studying the mapping process done frequently at Toyota to share information and identify ideal states for systems. John Shook had been using these type of maps for 10 years when he worked at Toyota, but he never thought to employ them as a tool to help people see. And really, the idea of value stream mapping is helping people see the whole of the process so we can decide what to work on next. Now, why would you do value stream mapping? The purpose of value stream mapping is to identify all the components of a value stream in its current state in order to determine improvement opportunities for the future. That future could be the next few weeks, months, or even year or more. Now, the reality, often value stream mapping is not employed until a business need arises, also known as the burning platform, or maybe we're starting a Lean Six Sigma implementation. Now, the definition, this is a definition of a value stream. A value stream is a group of activities that a business must do to design, order, manufacture, and deliver products or services to its customers. It is sometimes called value stream analysis, but it is most often referred to as value stream mapping or VSM. We'll say VSM. Now, why would we do value stream mapping? Well, from chapter 11 of Lean Thinking, remember this is one of the books that we promoted before by Jim Womack and Dan Jones back from 1996, so yeah, almost 30 years ago. Find a change agent, someone who wants to drive change in your organization. Then find a teacher or a sensei. Sensei is teacher in Japanese. Find a teacher or an instructor. Then seize some kind of crisis to motivate action across your organization or your firm. Then map the entire value stream for all your product families to know what to work on. Pick something important and get started removing waste quickly to surprise yourself how much you can do in just a very short period of time. Now, I've done value stream mapping hundreds of times. When I did my very first value stream map back in the year 2000, I didn't even know we were doing a value stream map. We just said, hey, what's our big picture look like and where do we need to go? Now, later on, I read Lean Thinking, I think it was later that year, and had a better understanding of why we did what we did. Now, how is value stream mapping different from process mapping? So we talked about process mapping in the yellow belt course. Here in the green belt course, we're going to move to value stream mapping because we want to do more defining and measuring and then analyzing. So in terms of DMAIC, remember define, measure, analyze, improve, and control. VSM is a defining, measuring, and analyzing tool that we use to identify opportunities to improve. It tells us where to do our projects, where to do our Kaizen events. A VSM workshop is more of a measuring, planning, and analyzing exercise than an improvement exercise. The improvements follow the value stream mapping effort. So we might do a number of Kaizen events or Kaizen blitzes following our value stream mapping, or potentially could be all Lean Six Sigma projects. Depends. Now, value stream versus process mapping. So at the top, you can see there is a value stream. I have sales and marketing working with engineering to create something. Then we have order entry and planning. Then we make whatever it is. Then we collect the money. We're driving value from the left to the right. Information is flowing from the customer back to the sales and marketing, and materials flowing from the left to the right towards the customer. Now, those are all different segments of a value stream. Below is an example for order entry and planning. That's a process. There's process steps that we need to do order entry and planning. It's a subset of the value stream. Another way to look at the levels of process are like this. The value stream is the highest level. It's at the top. It's how we deliver goods and services to our customers. Often value streams are product lines or service capabilities, maybe service and repair, or a particular product that you deliver to your customers. That's a value stream. Within the value stream, there are processes. And within each process, there's different operations. And at the lowest level, there's steps to each process. Those are the task level, closest to the process kind of thing. Could be assembly, order entry, whatever it is. Those are the steps I have to do to complete this. Now, in value stream mapping, there's a lot of different components. Let's look at them one at a time, and we'll dig into each in more detail. One, there's the processes. We just talked about processes. Could be stamping, molding, cutting, servicing, data entry. There's a lot of different processes. Then there's data or information transfer, so like maybe orders or signals. Then we have a lot of different times. First, there's lead time, then cycle time, takt time, T-A-K-T, takt time. Then there's setup time, and finally uptime. Lots of different times, 5 different times that we're going to look at related to value stream mapping. Then, of course, we have inventory in its 3 main states. There's raw material, work in process, and then finished goods. There's movement of product and of people. And then finally, symbols. So let's dig into each one of these in more detail. So what is lead time? The best way to describe lead time is to tag a part when it first shows up, and then actually make a note. And when does it actually leave the facility? That's probably a best description of lead time. What I often say is, imagine you just ordered something online, maybe from Target or Costco or Amazon. From the time you press enter until you receive it, that's lead time. That could be hours, or it could be days, or even weeks. So again, lead time is that time from order to delivery, and all the waiting and all the work that happens in between. Now, why would we want to reduce lead time? Well, faster responses to changes in customer demand, material cost and availability. We have smaller batch sizes. That would be a good thing to do to keep our lead time short. A batch size of 1 is ideal. Remember that from one-piece flow. We have a smaller work area, shorter travel time, less rework, errors and related waste, and improved mix for the customer. And then there's financial benefits, lower carrying costs, faster return on investment, and we reduce the cost of wasteful steps by having a very short lead time. So let's look at lead time, cycle time, and takt time. These get confused regularly. I'm going to say a few things that hopefully will help it make sense for you. So lead time is the total time elapsed from the input of the order to the output of the finished product. This includes delay, waiting, move times, all waste. Lead time is always the longest time. Cycle time, this is touch time, hands-on time, working time, processing time. This is the working part of it. Now, when you add cycle time plus waiting plus delay, then you get lead time. The only time cycle time and lead time are the same is when there is 0 delay, there is 0 waiting. Lead time can only equal cycle time when there is no waiting whatsoever. It's immediate. Now, the last time is takt time. Takt time is often confused with cycle time or work time or touch time. Takt time comes from what's our total daily working time divided by our customer demand or customer requirements per day. Takt time is different. It's not a Japanese word. It's a German word, kind of like blitz. Remember, blitz is short for blitzkrieg, which is a German word. Takt time can be defined as the maximum time allowed to produce a product in order to meet demand. It's the pace that we need to hold to have delivery. It's derived from the German word Taktzeit, which translates to clock cycle. Think of it like a metronome, right? Tick, tick, tick. It's that pace. Product flow is expected to fall within a pace that is less than or equal to takt time. In a Lean Six Sigma environment, the pace or the production drumbeat is set equal to the takt time. Now, how do you calculate takt time? Let's go through the calculation. This is important to know. So takt time, it's total daily working time, what's available, whether I have 1 shift, 2 shifts, 3 shifts. You decide what you want to do, and then you divide by your customer requirements per day. So let's do that calculation. My total daily working time is I have an 8-hour shift and I have 60 minutes. So I have 480 minutes. But wait a minute. I'm not actually working during breaks, but I am paying everybody. So I have to take that into consideration. So I have to subtract 30 minutes. And then I also have a kickoff shift meeting and a cleanup, which is 10 minutes. So I have to take that off. So I really don't have 480 minutes. I only have 440 minutes. So my total daily working time, the numerator of our equation there is 440. Now, in my customer requirements, my monthly volume in this case, we'll say is 2,200 units. There's roughly 20 days, Monday through Friday in a month. And so my customer requirements per day are 110. Now, when I do my takt time calculation, I take 440 divided by 110, and I get basically 4 minutes per order. If it takes me 4.5 minutes per order, I am not going to get all that I need to get done that day. I'm going to need to work overtime or I'm going to short ship my customer. Now, if I go faster than 4 minutes, like maybe 3.9 or 3.8, I'll get everything done and I might have a little bit of extra time to handle an issue or take care of something that comes up or do some training. I want to be at that 4 minutes per order pace or faster. So that's what takt time means. It just helps us understand the pace at which we need to operate. Now, setup time is yet another time that we have to think about. If you remember from setup reduction or SMED, single minute exchange of die, I want to have a fast setup time so I can go from one model to another model, one type of product to another type of product. Now, setup time is that total time elapsed from the completion of the last batch or processing of a particular type of product, form, or run to the first good product, form, or run of the next type of format. This includes delay, waiting, looking for tools, fixtures, data, all those wastes. Now, how would you reduce setup time? What does SMED mean? Remember, single minute exchange of die. The best way to reduce setup time is to make sure it's quick. It's fast. You can do it in less than 10 minutes. You're close to ideal when you're in single minutes, so 9 minutes or less. That's usually pretty reasonable. Let's look at an example of reducing setup time. So here we are. We've got a machine runtime in the before state. I run one of my lots and I say, okay, great, I'm done with that part number. Now I need to run a second lot of a different part number. I didn't do any work in advance, and so now I'm doing my internal setup and I'm losing productive capacity. Here's a better way to look at it. Here's after setup reduction. I run lot number one, and while lot number one is running, I do my setup, my external setup, stuff that I can do while the machine's running. Then I do my quick internal setup, which is short, and then I run another lot. Now, I just ran 2 lots, and the same time I only ran 1 lot because I got better organized and I worked on reducing my setup time. That's the essence of single minute exchange of die. Now, the last time is uptime. This is availability of equipment or of systems or of things to do what we want. Now, uptime is a percentage of available time that equipment is capable of meeting its production and it produces quality output. If I have a machine that's running but it makes junk, that's not going to be helpful. Now, Toyota believes that you cannot have true flow on any line that does not have a 99% or better uptime in total across all the machines. That means the aggregate uptime is 99% or better. That's a pretty tall order, but they do it. Now, how do you achieve that high uptime? What is TPM? TPM is total productive maintenance. TPM is how we have operators involved in maintaining equipment to make sure it runs essentially flawlessly from one service to the next. Now, sometimes that service level might be short or it might be long, but equate it to your car. I make sure that I change the oil, that I keep the air pressure in the tires so that every time I get in my car, I start it, it runs. I keep the battery in good shape. That's how you have good uptime, is good maintenance, good servicing. All right, we've gone through the 5 times. Now let's talk about inventory. Inventory is cash invested in the business where it occurs. Could be raw material we've purchased, could be finished goods, or it could be work in process. The goal is to reduce inventory everywhere possible. A value stream map can help us identify opportunities in the current state. Now, where is inventory or backlog the most valuable or expensive? And then where it is the least valuable? Where is it not as valuable? And why? Now, if you think about it, the most inexpensive material I have is usually my raw material. I've received it, I've probably put it away. I've invested a very small amount of labor to do that, but I've put in a fair amount of company cash to buy it. Once I start working on it, I'm at work in process. Now I've added more labor. It becomes more valuable, even if I do throw it away or scrap it. And then finally, when it's finished goods, it's the most expensive. I've put all the labor and all the raw material in it. That's the most expensive part of my inventory. So cheapest is raw, next most expensive is WIP, and then the most expensive is finished goods. Now think about finished goods. We build something, we put it in stock, and we hope someone's going to order it. What if they don't order it? Then I've actually made something that I'm going to throw away. That's very, very expensive. So again, inventory is an asset if you can sell it. It's a liability if you have to throw it away. All right, movement. So movement is conveyance of materials or movement of employees. All of that movement is technically waste. The goal is to reduce movement everywhere possible. A value stream map can help us identify opportunities in the current state. Now, what is an example of movement that a customer would say, yeah, I'll pay for that? Shipping, right? Shipping the product from your facility or your location to their location is an area that, most customers would say, I will pay for that. Movement's meaningful. Shipping it to me is meaningful. But what if I have to move it all over my plant floor or in from one building to another? Can we charge extra? No, there's no frequent flyer miles for moving things around our facility. The only movement a customer cares about is shipping it to them. All right, there's a bunch of symbols for VSM. These are the basic symbols. You would see these in a value stream mapping book. There's a process step, which is a box. There's outside sources, which is a quadrilateral. You can see that on the lower left. There's a data box, which highlights our lead time, cycle time, changeover time, all that kind of good stuff. Inventories are typically a triangle with an eye. Then you can see there's people, trucks. Movement is a solid arrow. Pushing of materials, like if I'm pushing things, here you go, here's all this stuff. Whether you need it or not, that's a push of materials, is a big dashed line. A supermarket, and imagine you're looking kind of like the aisles or the shelf in a supermarket on end there. And then finally, information flow, or the thin lines. So let's look at a fictitious value stream map. Here's the one I like to use. Imagine this is a place that makes cupcake mix or cookie mix. So I have my production control in the center running material requirements planning. They issue a weekly schedule to each of the areas: milling, mixing, filling, and shipping. I have a 6-week forecast I send out to Acme Supply so they know what raw materials we need, and I fax a PO over weekly. Imagine we still have a fax machine. And then Acme Supply sends us the raw stock every Tuesday. So day 2, they send us a week's worth of material, and then they deliver that in front of the milling operation, which is the first operation. So let's walk through this. In milling, I have one operator who does 500 pounds of milling at a time. Let's say they're milling for red velvet cupcakes or chocolate chip cookies or corn muffin mix, whatever it may be. They have to mill all the raw material down. And then if you notice down below that, there's a little box. That's the data box. I've got my cycle time, my C/T, that's 600 seconds or 10 minutes. I've got my changeover time, which is about an hour. That's long. But keep in mind, in food processing, you have stainless steel equipment. It has to be washed and cleaned up. You can't do red velvet cake and then do corn muffin mix as an example, one right after the other. You have contamination, so there's a lot of washing and cleaning. Now the uptime, because of that long changeover, the U/T is 85%. They only run one shift. Now, if you notice at the output of milling, I have about 10,000 pounds of work in process. That's the inventory there. I've pushed it out, I've milled it, and it's ready for mixing. Now there's all kinds of different, cake mix, cookie mix, and things like that ready to go. Now there's 2 people working in the next operation, which is mixing. There's 400 pounds that they mix at a time. You can see down below the cycle time of 300 seconds. The changeover time is faster, half hour. Uptime is 95%, so it's higher. And there's a single shift. Now at the output of mixing, I have 8,000 pounds of various work in process that are ready to be filled. The next operation is filling. They do 300 pounds at a time. You can see down below, cycle time 200 seconds, pretty fast. Changeover time 10 minutes, very quick. Uptime 95%. And then at the output of filling, you have 6,000 pounds of items that are ready to be shipped and staged and taken to federal distribution. So if you look at the distribution shipping size, they do about 100,000 pounds a month. There's one pallet equals 1,000. One shift daily, Monday through Friday, we get a federal distribution shipment out. Now, if you notice, federal distribution provides a 1-month forecast and a daily order to the production control people. So it's all connected. Now, down at the very bottom, you'll notice there's a square wave. That square wave is lead time and cycle time. My lead time is across the top. That's my days to run through the material or days to do the work in process. And if you look at that, I add all those up, I have 8.7 days of lead time. L/T is lead time. So roughly 9 days to go from the delivery of material to ready to go to federal distribution. Down below on the bottom side of the square wave, I have my cycle times, 600 seconds, 300 seconds, 200 seconds. My total processing time is 1,100 seconds, or about 18 minutes. It's not very long. But wait a minute. I've got a lead time of 9 days, but my processing time is 18 minutes. Why does everything take so long? That's the reason we do the value stream map, is say, hey, where are our opportunities? So here's another way to think about it. I've got this really long lead time and I've got pretty fast processing time, but I have all those cleanups where I have to wash all the stainless steel down to do the changeover. Now, why do I have such disparate, process amounts? I've got 10,000 pounds between milling and mixing. I've got 8,000 pounds between mixing and filling, and I got 6,000 pounds ready to be staged and shipped. Why is it all different? Why are we running different quantities? And then is it necessary to hold so much inventory between each process? I don't know that that makes sense. It's probably just been done that way because it's convenient. And then how about the changeover times? An hour is a long time. How come that can't be 5 to 10 minutes? Even a half hour is a long time. Why can't that be 5 to 10 minutes? What would it take? The only one that's close is filling. Now, can we balance the line so that the cycle times are the same, that we have something much closer? So again, this is just a simple value stream map, but it's highlighting some areas we could do improvement on. We might need to do some projects or some Kaizen events. Maybe setup production would be a good Kaizen event to do on each of the pieces of equipment, and then look at how we could balance the line. So again, this is just an example. We'll look at more value stream mapping examples in the next lesson. Remember, we have Learning to See, great book to tell you about value stream mapping. And then also the Toyota Way. This is kind of more the background, the philosophical understanding of Toyota, the 14 management principles that they use to really balance their lines and deliver great value to their customers. All right, that's for value stream mapping part 1. We'll come to value stream mapping part 2 momentarily. Thank you for your time.